to solve another Leetcode problem, 238, product of array except self. Yeah, so this just means, so for example, this is number 1, except self 1, it's going to be 2 times 3 times 4, it is 24, and for this number 2, it's going to be 12, and for 3, it's going to be 8, and for 4, it's going to be 6, yeah, because except 4, it's going to be 1 times 2 times 3, it's going to be 6. But how can we solve this kind of problem? Yeah, I think the easiest way is to use a prefix array and suffix array. We can solve it. Yeah, because basically there's also zeros inside the array. It's going to be difficult. So this means we cannot use the division to solve the problem. Yeah, so we have to prepare like two arrays, like prefix array and suffix array. And then for each of the number, for example, if we want to calculate this number, it's going to be some number before the prefix. Prefix is just the multiplication of some numbers, and the suffix is also multiplication of some numbers. It means we can use this number times this number, get the result. Yeah, so this is the we use some extra memory. Actually, we use the ON memory. Yeah, but for this video, I'm gonna explain the in place. Yeah, it means I didn't use any extra memory to solve it, but it's gonna be exactly the same. Yeah, so how can I solve it? Yeah, so for example, I have an array like this. We have 1, 2, 3, and 4. Yeah, now we are going to loop through the array, and because we're gonna return a result array, but this result array will not be the actual memory. Yeah, you must write algorithm that runs in ON time. Yes, we can use ON time without the division. We didn't use the division. And also, let's check here the follow-up. Yeah, in O1 actual space complexity. So the output array doesn't count as actual space. Yeah, so this means we can use an output array as the final return because it doesn't count as actual space. So this means we can use it. Yeah, because this is used for the space complexity analysis. Now we just need to use this kind of description. Yeah. Now we are going to prepare a result array. So this is the result array. So in the result array, as we know, for example, if this number is at this position for this number 4, what the result would be like? It would like 1 times 2 times 3, it's gonna be 6. Yeah. What about this position? At this position, it's gonna be 2. At this position 2, it's gonna be 1. Yeah. So what are we gonna prepare? From the beginning, we're gonna prepare all the positions to be 1. Next, we're gonna check from this position, I mean the second position. So from here, this just means what is the prefix multiplication before this number. So it is 1. So here will be 1. At this position, what is the multiplication before this number 3? Before 3, it is 1 times 2. So here we're gonna keep a 2. And at this position, we're gonna keep a 6. Because before 4, it is 2 times 3 times 1, it is 6. Yeah. Now our result array is updated to 1, 1, 2, 6. As we already know, 6 is our final answer. Yeah, because for this 6, it is except this number 4, it is 3 times 2 times 1. Yeah. And how to calculate it? We can just use a for loop, and from the second index, we can get this kind of result, because this is just like a prefix sum. Yeah, if we can get a result of this, now we're gonna solve it reversely. We're gonna solve it from the right to the left for this result array. Yeah, so for this result array, the first number has already been calculated, so we're gonna start from the second number. Yeah, so for the second place, which number we need to calculate? Of course, we need this number. We need a value before it. Yeah, so before it is this number 2. Yeah, it is also itself. Itself is also 2, because this 2, this number 2 itself just means how many numbers before it, and what is the final multiplication value. So it is 2. Now we need to use this 2 times 4, but how can we use it 2 times 4? Yeah, times 4 is okay, it is 8, but what about this number? It should times 3 and 4. Yeah, so this means we need to prepare a variable. So I'm gonna call it a total variable. Yeah, So I'm gonna prepare a total variable initialized to 1. Yeah. So at this position, so this total would times 4. So the total would be 4. So at this position, the total times itself is number 2. So it's gonna be updated to 8. Yeah. Now we go to this position. Yeah, and itself is 1. And what about the total? Total is 4. So this 4 should times this number 3. It is 12. So this position would be 12. And then we go to the first position. So it is 1 itself. So this 1 just means yeah, so this one just like a padding or prefix. It doesn't have any meaning. So currently our total is 12. So at this position, this 12 should times 2. It is 24. Yeah. So this means at this position, it's gonna be 1 times 24. It is 24. Yeah. So this is why we're gonna keep all the numbers to be 1 from the beginning. This 1 is just used easy for the calculation. Yeah, as you can see, 1 times 24, it is still 24, it doesn't matter. So this is why we're gonna keep it all to be 1. Yeah, now let's go back to the code. Yeah, so as I explained, I'm gonna use a variable n as the length of the nums. Now I'm gonna prepare a result array from the beginning, and it's gonna be 1 times n. And I also need to prepare a total from the beginning, it's gonna be 1. Yeah. Why we prepare 1 instead of 0? Because we used multiplication, not sum. So we should always use 1. Yeah. Now we are going to prepare the first step. So for I in range, from the first index to n. Yeah. So the result I should equal to, yeah, let's check it. Yeah, I don't have it, but yeah, so the result I, for example, this result I would be the second number at this position. Yeah, so it should be result I minus 1. Yeah, it should be result I minus 1 times nums I minus 1. Yeah. It means the number before it. So this is similar like the prefix sum. It is a DP, dynamic programming. So it's going to be result the number before it times the current number. It's going to be nums I minus 1. Yeah. Now let me print out the result to see if it is the same as I expected. Yeah. So as you can see, it is 1126. It means it is exactly as I expected, because this is the first, this position it is 1 and gonna be 2 and gonna be 6, and this first position is 1. It is okay. Yeah. Now we just need to loop from the right to the left. So for I in range n minus 1, yeah, I mean from the right to the left, the second last number, minus 1 and minus 1. First of all, we're gonna calculate the total. So this total should be itself times nums I plus 1. It's going to be the last number. For example, it is this number 4. Yeah. Now we're going to update the result. So the result I should be itself times the total. Yeah. So finally, we're going to return the result. Yeah. Let me just print out the result to see what it is. Yeah. As you can see, the result from the beginning it is 11626. Now it becomes from here 6 and then 8, 12 and 24. It is as I expected. Yeah. Now I will just delete the result, delete the print and check it again to submit. Yeah. As you can see, the time complexity we used 2 for loops. It is O(n), and the space complexity is O1, because this result is not counted as actual space. Thank you for watching. See you next time.